Okay, let us design monostable multivibrator. For monostable multivibrator, the circuit diagram is this. So we require one IC timer, and R1 is 100K, C1 is zero point 0.1 microfarad, and this you can use 0.01, and we require one negative going pulse, and one two signal generators or two oscilloscopes are required to see output voltage, then capacitor voltage, and the pulse voltage. So this is the oscilloscope used to see the pulse voltage, and this is used to find see the output of output voltage pin number 3 and pin number 6, that is capacitor voltage. So I will place one 555 timer, one resistor, two capacitors, and one pulse voltage and two oscilloscope. So the theory part, okay, that I think you can see the theory part. So this is a circuit diagram of RC phase shift, monostable multivibrator diagram. 4 to 8 is shorted, 7 to 6 is shorted. This is the R and C. The value of the pulse width output, this output is given by 1.1 times R and C. The output depends on the resistor value and capacitor value. Theoretical value of the output pulse width is 1.1 RC. So how many stable states this is having? Is only one stable, that is 0 only. Always output will be 0. Whenever you apply trigger here, in the pin number 2, if you apply a negative going pulse, at that time output goes to quasi stable state, and it will remain there with for a period of 1.1 RC. Okay, so the derivation and all, I think you can see T is equal to 1.1 RC. Okay, so whenever you apply pulse here, this is the pulse, trigger pulse. When you apply the pulse, at that time capacitor actually going to charge. Whenever capacitor charges 2 by 3 of VCC, then immediately output changes from high to low. So this is actually 0 is actually stable state. When you apply trigger pulse, that time it will go to quasi stable state. After duration of pulse width of 1.1 RC, this width is 1.1 RC. That pulse width is, see the derivation, it is 1.1 RC. Then again it will come back to this one. So it will be there for uh, time until you apply negative pulse, one more pulse, it will be there. So this is a stable state. 0 is stable state. If you apply one more pulse here, if you apply one more pulse here, again it will go to quasi stable, and it will remain there for 1.1 RC. Okay. After that, again it will come back to stable state. So it is having a only one stable state, that is 0. That's what's called as a monostable. And the width of the pulse which is going to quasi stable, that is 1.1 times RC. So this RC will decide that. So let us do that now. So I'm going to rig up the circuit. So go to place component and select in the mixed. In the mixed timer is there. So select LM555CM. Click OK. So we take on this. After that I require one capacitor and resistor. So go to basic. In the basic select resistor. Click OK. Control R to rotate. Then capacitor. Click OK. Control R to rotate. One more capacitor. Click OK. Control R to rotate. And we require power supply. Go to sources. Power sources. So in the component nothing should be there. So click VD or VCC. Click here. Then ground. Two grounds are required, two or three. So we can go to that. So one ground here, another ground for first oscilloscope, another ground for second oscilloscope. So 3 grounds. Now you have to do the remaining connection. Okay, first I'll short this one to here. So next this capacitor is shorted to this. So now this resistor is connected to this 4 is shorted to 8th pin. Then pin number 7 is shorted to this. So first I have to short this trigger. I have to short here. Pin number 6 and 7 shorted. Trigger is given with pulse. So I will take a pulse output here. Pulse input I have to give here. Double click and end here. After, otherwise you can put a pulse input here. So next this capacitor. These two capacitors are shorted to ground. I require 2 oscilloscope. One you place here, another one place here. So 2 oscilloscope, because 3 waveforms we have to see. One you connect to the output pin number 3. Second one to capacitor voltage. Capacitor voltage, I think it is here. This is the capacitor voltage, and let me take this value as 0.1 microfarad. 0.1 microfarad. You can choose, that is decided by you. So whether it is how much T you have selected. 10K. So we will check with for different values of that. You have to give one more pulse here. For that again place component V pulse in the power supplies. We require pulse voltage. This is AC power. In the signal voltage source, I think you can get pulse voltage here. That pulse voltage you select, click OK. And we require one so this pulse voltage is, you can vary from initial voltage. You can let me give 5 volts, and when you press, I should go to 0 volts or minus 5 volts. Let us take delay is this much, and duration you can give it to some 10 millisecond like that. Okay, for every 10 millisecond, initially it will be 5 volts. After 10 millisecond, it will go back to minus 5 volts, that is negative going pulse. Again it will come back to plus 5 volts. Okay, for every 10 millisecond, one negative going pulse is going to generate from this. Okay, so that if you want to see separate output, you can collect. So this is, instead of that, I'll take 2 channel. So negative is grounded, positive is connected to see the pulse. So plus, initially plus 5 volts. After 10 milliseconds, it should go to minus 5 volts. So in the 5 volts, this minus 5 volts is for small time. Okay, again it will come back to plus 5 volts only. So now I'm going to start the simulation. This negative is, this ground is missed. So I will connect this one to this, and one more, this negative, both the negatives of this connected to this. Okay, negative channels, negative of the both these channels are grounded. First one is connected to the pin number out, where you are going to get pulse, which is 1.1 time RC, and another is capacitor voltage, to see that capacitor voltage. So that capacitor voltage you should get this type. Okay, you should get capacitor voltage. I'll show you. Capacitor voltage is this. Capacitor voltage is this. So capacitor voltage starts from 0 to 2 by 3rd VCC. So if the VCC is 5 volts, around 3.2 volts, when the capacitor voltage reaches 3.2 volts, immediately output of pulse width should go to from high to low. So this width is 1.1 time RC, and this is the pulse. Initially at 5 volts, when and it goes to minus 5 volts, which is less than 1.3 volts. At that time, it is going to set the flip flop. So capacitor is going to charge through, or once it reaches 2 by 3rd VCC, the upper comparator are going to reset the flip flop. So output will changes from high to low, and whenever you apply pulse, that time only it will go to quasi stable, otherwise it will remain in stable only. So now let us check this. Just should be an interactive simulation. Now you have to double click this. First we want to see the pulse. Now double click on this. See, here you can see the pulse. These are negative going pulses. See, it will be at 5 volts. After 10 milliseconds it is going to negative. Again it will go there. Okay, this is pulse. Coming to output. So now we can see this. See, both capacitor voltage and this one both are there. So I am going to ground this. I will reverse this. So you can see I am going to ground anyone. See, now capacitor voltage is grounded. So we are going to see pulse. This width, if you measure, it will be approximately 1.1 value of R and C we used. Okay. So if I take single, you can see this. Okay. And if you want to see only capacitor voltage, then you give only, you ground this one, you ground this one, you ground. This is only capacitor voltage. If you want to see both, and if you want to offset, then position Y position you make down. Okay. So this initially capacitor voltage is 0. When it reaches 2 by 3rd VCC, this voltage output will, and actually pulse will come here. Actually the pulse also will come here. Actually the pulse, whenever you apply the pulse, that time capacitor voltage starts from 0 to 2 by 3rd VCC, and this will be, and this output will be quasi stable. Whenever capacitor voltage reaches this, immediately output changes and it will come back to this, and one more pulse is applied here. So actually I used two separate CROs. So instead of that I can do only one. You can see I want to use only one, where you can have 4 channel undo. I think if it is replace by sub circuit. Okay, it's not possible. So I will delete this. I will use 4 channel. I'll use. Okay, one I will give it to here. Okay. The second channel I will give it to capacitor voltage. Okay, one minute I will do. First, let me give you. Let me take. First, I'll give it to input. Okay. Let us see one by one. First, let me give it to input. I want to see the input now. Input pulse is connected to the pulse. First channel is connected to the pulse. Second, let me give to capacitor voltage. Capacitor is, where is capacitor? Here. The capacitor voltage. Third one is here. This is ground. So now let me run this. Now all the three are available. So I will give different colors for different input. Let me give the color. Right click. First you have to stop the simulation. Right click and set the color to input. Now I'll give blue color. Input blue color. Then output I'll give some green color. Dark green. Then I'll give this capacitor voltage with another color. So three different colors. So let it be some blue pink color. Okay, now run this, double click on this. So the three different colors are coming. So just run this and double click on this. So three different colors are, you can see. So I'll decrease the time. So I'll place all the three above. So now it is in channel 1. So channel 1 position I will make Y position to go up per. So the pulse is there. Okay, and that scale division I will make it 2. Sorry, 5. That position I will make go upper side. Okay, then next channel I will change this one to B, channel B. Channel B, the position, I think capacitor voltage. Okay, capacitor voltage, let it be here in the middle only. Now coming to channel C, then I will make the position to go down. All of you please observe. This is similar to what we getting there. So if you want only single side, you can click single, and if you want to invert, reverse the color, you can see here. Whenever you apply pulse, see, whenever you apply negative pulse, capacitor starts charging and it is keep on charging from 0 to VCC. So whenever it reaches 2 by 3rd VCC, this voltage, okay, this voltage. So if you want, you can check the voltage level value here. So this voltage is around 3.3 volts. Channel B, you can see 3.4 volt is there. So whenever it reaches that, immediately the output changes from high to low. Okay, so it will be stable, it will remain there in the stable state. One more pulse is here, one more pulse is here. So that pulse comes, that time again it will go to quasi stable. So this is called as a monostable. Monostable means single stable state. It will be there in the zeros. When you apply trigger pulse, immediately it will go to quasi stable. And this width is given by 1.1 RC. So let us check what is the pulse width of this. So it is T2, blue color cursor and red color cursor, two cursors are, you can see T2 minus T1. What is how much? 1.1 is there, 1.1 millisecond. So let us check theoretically whether our answer is correct. I will take a calculator. We used uh, we used we used R as 10K, C as 0.1, R as 10K, C as 0.1. So if you check the answer here, 1.1 times 1.1 times R is 10K, 10K and zero point 0.1 micro. This is 1.1 millisecond. 1.1 R value is 10K, C value is 0.1, 1.1 millisecond you should get. Practically also, in the simulation also you can see here, it is showing 1.1, T2 minus T1. T2 minus T1 it is showing 1.1 milliseconds. So this is monostable multivibrator and its output. Okay, thank you.